Guys, this is Casey here with Aladdin Carpet Cleaning with Live-Built Truck Mounts. Recently, the Boss vacuum filter was introduced on tmfshop.net, and we just wanted to kind of show you a little more about what it is and what it takes to make it and what it's made out of. So basically what I've got is all the parts here that we start with, okay? We've got an 8-inch outside diameter aluminum tube, all right? This is not just wrapped and rolled paper thin sheet metal. We actually buy the tubes. You can see right there, it's stamped on it, what it is. We just get these are 18 inches long, mill finish, is how we get them. That's basically the body of the filter. We've got our lower chamber right here, also 1/8 inch thick aluminum. Our back plate, our front plate for the body, then our lid piece, okay? All of the inlets and outlet tubes are also 1/8 inch thick aluminum tubing. This is what we start with. Cut all these up. There's a lot of work to be done on this yet. These are just basically the raw parts. All of the hardware on it that holds the lid on is all stainless steel. We've got our stainless steel nuts, stainless steel washers. Our small ones are bolts that actually hold the mounting hardware onto the body, also stainless steel. Then we've got 2 bolts per each filter that go through these stainless steel plates, okay? We had all of this stuff water jet cut, so everything's exactly the same. One of the things that makes this a lot of work is the fact that when this comes off the water jet, these edges are, I mean, just razor sharp. So along with the polishing, we have to knock down all these edges, and what we do is we knock them down with a grinder, and then we actually go back and sand them with a 220 grit sandpaper so that they're really smooth. I mean, I would never draw this across my arm right now because it would definitely cut me. That's what we start with, and you can see that there's a lot of work to do, so I'm going to show you what the next step is. Okay, we've done quite a bit of grinding and polishing and everything here to make them nice and shiny and clean. We've got our back tubes here that are cut up. I don't have any of the front tubes sitting here because I didn't cut any up this morning, but the back tubes are slightly shorter than the front tubes, and I'll show you why here in a few minutes. But we get those polished. We knock down all these edges right here, again with the grinder, so the hoses can go on and off very smoothly. I also didn't show in the first video the handle, all right? This is 3/16 of an inch thick marine grade aluminum. I also didn't mention that the front plate of the body is 3/16 of an inch thick marine grade aluminum, as well as the lid, okay? The body and the tubing is 1/8 inch, this is 1/8 inch, the back is 1/8 inch, the front is all 3/16. Really didn't want those collapsing or moving under pressure. Also, one of the things that we ran into on the prototypes was with welding them, we were getting a little bit of a warpage. So what we had to do when we welded them was actually make a heat sink underneath it, where we used 2 pieces of 1/2 inch thick aluminum. When we set this on there and weld it, it draws the heat out. Really, it didn't eliminate warpage, but it reduced it. We went back later and actually used that to our advantage, and I'll show you that here in a few minutes too. But you can see these are all nice and polished, and on the front of this, I hope you can see, the 2 of those we've actually countersunk. Those are going to hold in the hardware. Those are those little bolts I showed you before. The other bolt comes through the front, okay? The other stainless bolt. We welded those stainless bolts into the stainless plates, and this is all, of course, stainless wire and everything that we used. So those are going to become our mounting hardware. Also, I had mentioned before that the edges were razor sharp when we first get them. They're not anymore. Like I said, we make sure that every single one of these is really nice and smooth when it leaves here. That was one of the first questions I got when I built the first prototype: is that thing going to cut me? Absolutely not. You know, the handle's on here. We make sure everything's nice and smooth. What we do to the body here, after we polish it out, cut that channel in it. That channel will be on the bottom when it's done. This piece fits on there. That gets welded on. That way, when that's sitting down, which you can see, finished one, that's at the bottom. Even if you didn't have vacuum hooked up to this, if you stuck a garden hose in the front, the majority of the water is just going to roll right out the back. What we didn't want is for it to pool water. That's one of the major complaints that people always had with other filters, is that they finish a job and they have to dump out a gallon of water out of the filter. The other problem with that is how it affects your airflow. It would be like trying to picture skimming water off the top of a swimming pool. All right, instead of it going through, the filter fills up halfway, and then you're skimming water instead of getting a smooth flow all the way through. That's one of the purposes for that. You also can see how that hardware goes on that one too. I'll show you. This is why the front lid tubes are a little bit longer. We actually weld them on the back side. Now you might notice that that's not as pretty of a weld as a TIG weld, and that's because these are MIG welded. And the reason is because we're getting so much warpage trying to weld those two little things right in the middle. What we did is we made a jig. This sits in it, keeps the tube straight so that they're pointing nice and straight, and then we welded them on the back. So whatever warpage we do get actually works for us. It'll warp in a little bit at the bottom and a little bit at the top. We actually remanipulate these on every single filter when they go back together to get a really nice vacuum seal all the way around. And I'll show you that here in a few minutes too. So everything is polished, ground, sanded, and we're ready to go fit, tack, and weld. Okay, I really spared you all the details of all the welding and everything to put this together. Obviously we welded it, we put all the hardware on, and now it's a finished product. You can see, like I was stating before, water comes in at the top, flows down, goes down at the bottom. I've got our tube sticking out here, tube sticking out here. I've had some people ask, you know, what if I only want one port, to use one port on the back and one port on the front? Well, there's an easy way to do that. We use a 1.5 inch quick cap. You can get this at pretty much any hardware store. Now, the reason you get a 1.5 instead of a 2 inch is because these are pipe sizes, which the outside diameter of a 1.5 inch pipe is 1 7/8, okay? The outside diameter of a 2 inch tube is 2 inches. So, you can place these on there, and they're tight. Whichever port you don't want to use. You can use go ahead and use the hose clamp and tighten it down there if you really don't ever plan on using that, even if you do. But the fact of the matter is, those fit so tight that you really don't even need this. However, you know, just to be safe, you might as well go ahead and put it on. You can put one up here, one back here, and you can run a single 2 inch hose from each side. I really recommend that you run 2 hoses from your recovery tank to the back of the filter. It makes a big difference, even if you only do it for 10 or 15 feet. It's a lot easier to suck air into a recovery tank through 2 holes than one. It would be like if you were drinking out of a straw, you drink out of 1 straw, you kind of have to suck on it. You drink out of 2 straws, it comes out way easier. So that's one thing I wanted to cover in that, because people ask, why did I build them all this way? Well, when it's all welded construction instead of little bolt-on caps that are probably going to leak air, leak water, everything else, I needed to make it to where it would work for virtually anyone. We also have a version with a single 2.5 inch hose on the back. I'll show you that here in a minute. A couple other things I wanted to cover. People have asked, why the clamping knobs? Okay. We spent an awful lot of time looking at how are we going to put this lid on, how are we going to make this 100% airtight. This was the way to do it. I had mentioned in the previous video that we'd get a little warpage when we were doing the welding and everything, and we made that work to our advantage. Instead of just remanipulating these lids back to flat, we actually concave them at the top and bottom towards each other. That way I didn't have to put 4 clamping knobs on it instead of 2. So what happens is, when you clamp this down, the top and bottom actually touch each other first. So when you clamp this all the way down, this is really highly pressed together on the areas and has kind of a spring action that just sticks it together. It's 100% airtight. These are really not that hard to take off. I'm taking them off is nothing. Putting it back on takes a second. I mean, I don't know why anybody's really complaining about that, but people are are making comments about it. Putting it back on, you may notice, and because we do it by hand, that not every one is exactly the same. Some are a little more concave than others. But as you go on this side, tighten that one down. Sometimes it's going to pull this other side of the lid out. Just hold it down, get it on there. It's fully sealed. You know, maybe a latch or a bungee cord might do that in maybe half that time, a couple of seconds faster. However, they're not going to stay like these are. The stainless steel bolts on the back, the knobs here are plastic, obviously, but even if you broke one of these, and I did one time, I got a little crazy and showed somebody how strong this was, and I threw it about 50 feet. It broke one of these. The underneath there is actually a flange nut, so you're not out of business. You can just hold that down and tighten down your nut. If you ever needed to replace one of these because you lost it or broke it or anything, these are also available at a lot of hardware stores. It's just a 5/16 clamping knob. If you really wanted to go cheap, you could just use a wing nut, all right? Part of that also goes with the gasket material that we used. What we used here is a 3/16 thick on each side. So once this is put together, you've got 3/8 of an inch of gasket. It's an EPDM blend is what it is. It's EPDM, neoprene, and SBR, closed cell sponge rubber, okay? It's basically impervious to gases, fluids, liquids, ozone, that sort of thing. These gaskets are going to last a long time, and that's what I wanted. I didn't want this thing to start leaking in a few months. With all welded construction, why mess around on the front? So we got real serious with it. We've been cutting all these out by hand, by the way, so if you get it and they're not quite perfect on the outside, it's because it would have cost a considerable amount of money to have them die cut or water jet cut. On the next run, we probably will do that because honestly, it's not that much fun to sit down and cut these out all day long. But that's what we did on this first run. The other thing is this handle. I've had people ask me, why is mine crooked? Well, it's supposed to be like that. The way we set these up, when I first made the prototypes, these were perfectly flat. I had somebody say, you know, if you angled that down a little bit, it might be a little bit easier to manipulate. It's very ergonomic. So we angled them down just a hair. One of the things on other filters, people say, hey, if I have to rinse it out, you know, can I stand it up and rinse it out, that sort of thing. You really don't need to do that with this because you can hold it like this. With this lid off, you can just go ahead and spray it out and all the water goes away from your feet and everything. If the handle was mounted in the middle, right here, that would be a really awkward position to put it in. So basically that's about it. You can see how the hardware is all installed on here. I did want to cover one more thing that after Rob had put this on TMF, somebody had mentioned, what do you mean by reinforcement tack welds? We're going to show you the basket. Right? What we did on the prototypes is we used basically the exact same dimensions of an RC99 or silver bullet filter. Okay. What we did though is we used a finer mesh. This is basically could be used as just a filter instead of a bag holder. We also used a slightly thicker top ring and bottom ring and a slightly thicker wire. We had these contracted out to a company in Georgia and they went overseas with it. I was a little disappointed because all the rest of this is made in America. All of this aluminum and everything comes from US based mills. We have all the water jet cutting done right here in Grand Junction, and honestly we do all the welding right here. So however, I will say they did a fantastic job. These came out really nice. The rings aren't warped, they're perfectly straight, and they use nearly 100 resistance welds to put this together, to hook it to the rings and to do the seam. Well, here's the problem. Resistance welds are basically putting an electrical current through that basically just melts the two metals together. That's the way manufacturing is done on things like this because you have a thicker piece and a thinner piece. I wasn't really happy with that because we used materials that are going to last forever. They're a lot more durable than anything else out there, And I thought, you know, the only thing that's going to happen to this is those resistance welds are going to start coming apart and it's going to fall apart. It took me quite a bit of time, and I had to sacrifice a couple of these to get down how I could actually add a weld with filler metal on them. So when you get one of these and you see these little tack welds around it, that's me. I sat down and did every single one of those. I had to use a silicone infused stainless steel welding wire and a helium trimix gas, and it took me quite a while to figure out my settings, wire speed, and everything. We looked into TIG welding them. It was just too time consuming, and by the time you got any kind of penetration into this ring, you were just disintegrating the wire. So I got it to where I would get good penetration into the ring. You can see we've got a good heat signature there, and it just grabs the wire. That's going to make this basket last probably 20 times longer than it would have straight from the manufacturer. I also did a few right down the seam, and those caught a little bit without putting holes in it, and I did just a few around the back. I wasn't that worried about the back. Most people are going to use a liner anyways, and that one was really hard to do, just so you know. But I think those are going to last forever. We didn't want to put something out. I'm really not in the business of saying, hey, we want to sell you a new filter basket every 6 months. We want this one to last. If it does start coming apart, guys, take it down to a welding shop and have them fix it. All right, this should last you probably the rest of your career. Well, I think I've covered about everything. Did have a little fun yesterday, which I rarely ever do, going out and making a video just to kind of show you how strong this was. And it was fun because somebody on TMF made a post saying, hey, send it to me, I'll see how strong it is. And then he posted a picture of a video he made a few years back, which I really enjoyed. I thought it was a great video. I decided to go ahead and do one of my own in that fashion. And I don't know if it's going to come out before or after this one. It'll be in the next few days, but I hope you enjoy that one. It was kind of fun. I hardly ever get out of the shop. I know, I'm being signaled over here to show the 2.5 inch back. So, let me show you that. Again, 1/8 inch thick aluminum tubing, all welded construction. We didn't need to do the chamber on the bottom of this one because we can just place this right at the bottom. So we've sold a few of these on the 2.5 inch back. Not very many guys run 2.5 inch hose, but the guys that do are pretty serious about their suction. I still believe that the 4 to the door or the duals is better, and you can actually go on YouTube and look up a Rob Allen video from several years ago. It's called 2.5. It's called 4 to the door versus 2.5 vacuum hose for vacuum. Pretty amazing the CFM ratings that he was getting from a single 2 inch hose to a dual 2 inch hose to a single 2.5. But this is what we've got on the back of the 2.5s, and we've still got the dual 2 inch front. So anyways, that's about it. I hope that covers everything, and knowing me, I'll think of something else about 5 minutes from now and then not want to redo the video, so it'll be in writing. But that's about it. Thanks for watching.